So we're going to go ahead and get started, and we're going to begin in Chapter 1, Section 1. And we're going to begin by talking about equations and expressions, and then we're going to talk about the three basic types of equations. You're probably already familiar with these, but we're going to go over them. I always like to go over definitions, because in math we use definitions and you need to make sure you have a good vocabulary. So we're going to start off with the definition of an expression. So we'll talk first about what an expression is. And so an expression has no equal sign, and it cannot be solved. Now you might be able to combine like terms, but you're not going to be able to solve it. So here's some examples of expressions. (5x minus 4). That's an expression. 7x squared minus 3. That's an expression. How about the square root of 3x minus 9? Those are all examples of expressions. Now with an expression, we cannot solve it for a variable. We can't solve it. We might be able to combine like terms together, but an expression has no equal sign. On the other hand, an equation has an equal sign and can be solved. For a variable. We should already be familiar with equations. So let's look at some examples. 4x minus 5 equals 2. That's an equation, and we can solve it. 9x plus 2 equals 4. That's an equation, and we can solve it. X squared minus 3x equals 4. That's another example of an equation, and we can solve that. Now the last one, you may or may not have a lot of experience solving these. The first two, though, you should probably be already familiar with. Move variables around and solve them. So that's the difference between an equation and an expression. Next, we're going to talk about linear and nonlinear equations. So we'll begin with nonlinear. And for nonlinear equations, these have powers, roots, or x is in the denominator of a fraction. So these are all going to be nonlinear. So 5x squared plus 3 equals 2x. That's an example of a nonlinear equation. The square root of x minus 9 equals 4. That is nonlinear because of the square root. 3 over x minus 7 equals 9. That is also nonlinear because the x is in that denominator. Now, this is going to be the second half of Chapter 1. The first half is primarily going to be linear equations. And so we've talked about nonlinear, but what are linear? Linear equations They don't have any powers or any roots. So these are all linear. So linear equations have no powers or roots. And so some examples of linear equations would be things like 3x minus 7 equals 4, 5x plus 2 equals 1, and let's say 9x equals 0. Those are all linear equations, so no powers and no square roots. So let's take a moment to discuss what we've covered so far. So we've talked about equations, we've talked about expressions. What's the difference between an equation and an expression? The equal sign, right? Now, primarily in this course, we're going to be focusing on equations. Once in a while, we'll do an expression, but mostly it's going to be equations. And then we talked about linear and nonlinear equations. Nonlinear equations have square roots and powers. X might be in the denominator of a fraction. On linear equations, these are things that you're probably already familiar with. You probably solved a lot of these in your previous algebra courses. And this is what we're going to do today. Is we're going to focus primarily on linear equations today. And then next week and throughout the rest of the course, we'll focus on nonlinear equations. So today we're going to focus on linear equations. And there are three basic types of linear equations. The first one is a conditional equation. And what's special about a conditional equation is you can solve it and you'll get a numbered answer out. So here's an example of a conditional equation. About 3 times 2x minus 4 equals 8x plus 1. So we're going to be solving this. And when we solve it, if our answer is a fraction, we keep that fraction. So don't use a decimal unless the problem has a decimal or it's an application. But most of the time, if we have fractions, you'll want to keep the fractions. Well, what do we need to do first? Well, the first thing we look at is our order of operations. So we're going to distribute through that 3 in front. And that gives me then 6x minus 12 equals 8x plus 1. And we should know how to solve this. What's our goal? Well, our goal is to get the variable x by itself. So I'm going to move the 8x over with subtraction, and I'm going to add the 12 over to the right-hand side. So 6x minus 8x makes it a minus 2x. The 12's can cancel. The equal sign comes down. The 8x's can cancel. And 1 plus 12 makes it 13. Divide by your negative 2. And we're going to rewrite this as x equals now a negative 13 over 2. We always bring the negative up to the top. So you never want to leave a negative in the denominator. You want to bring it up to that numerator. And this is called conditional. And why is it called conditional? It's called conditional because we were able to solve it for an answer. There's a condition that makes it work, makes it true. And that condition is minus 13 over 2. Next, we're going to look at the identity. So that's conditional equation. We looked at an example of that. Next, we're going to look at the identity. And for the identity, the sides are the same. So the sides are the same, and the solution is all real numbers. Now, when I think of identity, I think of identical twins. And what do we know about identical twins? Well, identical twins are the same, right? And so when we solve an identity, that's going to make the sides the same. Now, it may not look like they're the same at the beginning, but once we do some algebraic manipulation, the sides are going to match up, and they're going to be the same. So let's look at one of these. It's going to be an identity. About 3 times x plus 4 equals, how about 2x plus x plus 12. Now, these sides don't look exactly the same to start with, but after we use our distributive property and we combine like terms, you're going to see that they are the same. So when we distribute that 3 through, we get then 3x, and 3 times 4 is a 12. On the right-hand side, we have a 2x and another x. That makes it 3x plus 12. Now, these are the same. And when we talk about an identity, what it means is no matter what number we plug in, from 0 to minus 20 to positive 50, the sides are always going to match up. It's always a true statement. So these are the same. This is an identity. And your solution set would then be all real numbers. Some instructors use negative to positive infinity, and that's okay too. I just try to follow our textbook, and our textbook has the answer as all real numbers, so that's what I use. If you want to use negative to positive infinity, that's okay as well. But the important concept is that this is an identity because the sides are the same. Now, what's the opposite of an identity? That's a contradiction. Identity means it's always true. Sides are the same. A contradiction means it's a false statement. So when we talk about a contradiction, we're going to be talking about a false statement. And this is an example of a contradiction. When we go to solve this out, the variable x is going to disappear. And we're going to end up with two numbers that don't make sense. They don't equal each other. So when I distribute this 5 through on the right, the left stays the same as 5x plus 2. The right-hand side becomes 5x minus 15. We move that 5x over with subtraction. And then we're left with 2 equals a negative 15. Well, obviously 2 does not equal a negative 15, does it? Right? That doesn't make sense at all. So this is a false statement. And what happens when we have a false statement? That's called a contradiction, and we have no solution. And we express our answer as a 0 with a slash through it, and that is called your empty or your null set. So empty or the null set, Depending upon the textbook, it might be an empty set, or they might call it the null set. So now we've covered equations. We've covered some very, very simple ones. We're going to now spend some time going through some problems that involve fractions. A lot of times students struggle with equations that have fractions. What we're going to do is we're going to clear them out and solve the problem. Many times students look at a problem that has fractions and something just goes off inside of them and they just kind of panic. But we're going to get rid of those fractions and make the problem a lot easier. So I'm going to pick a few of these from our textbook here. And again, we're in chapter 1, section 1. We're not going to cover the review chapter. You should have had that, hopefully, in previous courses, and we also cover part of it as we move along through this class. So let me find a couple of problems from our textbook here that have fractions in them. I'm on page 110. We're going to begin with question 16. And we've got 7/4 plus 1/5 x minus 3/2 equals 4/5 x. So this is what we're going to work with. This problem is not going to be difficult to solve. It looks intimidating because of the fractions. We're just going to get rid of the fractions. And how do we get rid of the fractions? Well, we get rid of the fractions by looking at the least common denominator. And we're going to kind of group these together. So I'm going to group this 4 and this 2 together. Now, what's the least common denominator of 2 and 4? Well, the smallest number that goes into both of them is 4, right? 4 goes into itself, and 4 also goes into 2, twice. Then we take our least common denominator of the 4 that we just found, and our other fraction, which is a 5, in the denominator, and the least common denominator of 4 and 5 is going to be a 20, isn't it? How do we clear our fractions now? Well, what we do is we multiply our entire equation by 20. That's my least common denominator, and that's going to clear them out. Now, how does this work? Well, when we multiply that 20 through, we divide it by the number down below, multiply it by the number on the top. So we're going to go ahead and multiply this all by 20. And we'll go through it step by step so you can see how we clear these fractions. On the first one, we divide and then multiply. So 20 divided by 4. Well, 20 divided by that 4 below is a 5, right? And then 5 times 7, that makes it a 35. We divide by the number below, multiply by the number on the top. The next one, 20 divided by 5, that's a 4. 4 times 1x makes it a 4x there. Next, 20 divided by 2, that's a 10. And 10 times a negative 3, well, that makes it a negative 30. Just remember, divide, multiply. Divide, multiply. The last piece is 20 divided by 5. Well, 20 divided by 5 is a 4. Times 4 makes it then a 16x, doesn't it? So now all of our fractions are gone, and we can begin working on solving this equation. I'm going to begin by moving that 4x over. And then I can combine that 35 and that negative 30 together. So I'm going to move that 4x over. And then I'm going to combine that 35 and that negative 30. So 35 minus 30, well, that leaves you with a 5. And 16 minus 4, well, that leaves you then with a 12x. How do we finish it? Divide by our 12. And then we'll rewrite this as x equals now 5/12. And what type of equation is this now? Is it conditional, contradiction, or an identity? Can someone tell me? This would be conditional, right? Why is it conditional? Because we have an answer. So this is conditional here. So that's an example of a problem that has fractions. We cleared the fractions out. We're going to try another one of these, and then we'll move on and we'll look at literal equations. So let's look at one more that has fractions, and we're going to look at question 22. So same page again. Question 22. So we're still on page 110. We're going to look now at question 22, and it has fractions as well. In question 22, we've got 1 over 15 times 2x plus 5 equals 1/9 times x plus 2. Again, begin, distribute through, parentheses always must be done first, so distribute that 1/15 through, and distribute that 1/9 through. If it helps, you can write these over 1. So this is a 2 over 1, and a 5 over 1, x over 1, and a 2 over 1. I normally don't do that. I normally don't put the 1s there. I am in this case because we're learning how to do this. You should already be familiar with how to solve this, but if you're not, we're going over that today. So what we do is we multiply. So 1 times 2 is a 2x. 15 times 1, well, that's a 15. Next, we've got 1 times 5. Well, 1 times 5 is a 5. 15 times 1, well, that's a 15. Next, we've got 1 times x, that's an x. 9 times 1, that's a 9. And we've got a plus. 2 times 1 is a 2. 9 times 1 is a 9. Many different ways of solving this. You could have distributed it through, combined them together in one fraction, and cross-multiplied. I chose to just work it out this way. What's the least common denominator of 9 and 15? Does anyone know? Least common denominator, 9 and 15. Okay, well, 3 wouldn't work because you've got to have a number that goes into both of these. Now, what about 45? Would 45 work? Yeah, 45 would work, and it's the smallest number. Because 45 over 15, well, that is what? 3, right? And 45 divided by 9, well, that's a what? 5. So we want the smallest number that goes into both of them. They have a multiple of 3 in them, but we're looking at the number that I can use to clear out these fractions. And that in this case is going to be a 45. So now we'll put our 45 in front. And we'll start distributing through. Now again, what are we going to do? Divide by the number below, multiply by the number on the top. So 45 divided by 15. Well, 45 divided by 15 is a 3, right? And 3 times 2 makes it a 6x. We could have, by the way, reduced this 5 over 15 down to a third, but we really don't need to because we're going to get rid of the fractions anyway. So I didn't bother reducing. We just clear them out. So we've got 45 divided by 15. 45 divided by 15 is a 3. 3 times 5 makes it 15. Next, 45 divided by 9, that's a 5, times x, that makes it 5x. 45 divided by 9, that's a 5, times 2 makes it 10 there, doesn't it? Now we should know what to do. So move that 5x over, and move that 15 over as well. That's then going to leave us with x equaling now -5. We have an answer, so this would be conditional. And why is it conditional? It's conditional because we have an answer. Everyone okay with that so far? I want to do one more of these just to make sure we know how to handle this type of question. So very similar. You'll see this problem also in your homework, or one like it. So let's try to work out this one. This one is no more difficult than any of the others. It looks a little bit different though. Now, what we're going to do is we're going to separate them out into individual fractions. Then we're going to clear the fractions. So we're going to take our first part here, and this actually has 2 fractions in it. So we're going to take this and we're going to divide it out into 2 separate parts. So that would give you then a 4x over 3 plus 3 over 3. And we could write that 3 over 3 as a 1 if we wanted to, but it doesn't matter because we're going to clear these fractions out in just a moment. So you can either write it as 1 or 3 over 3. Repeat the process here. The only reason I'm breaking it up is so you don't make a mistake. If you try to do too much at once, a lot of times students will make a mistake and distribute 3 rows. So we're going to split this one up into the 2 pieces as well. And then over here, split it up also. And that's going to be x over 12 minus 1 over 12. And we need a least common denominator. Well, least common denominator of 3 and 4 is going to be 12, isn't it? Okay. And the 12 will clear out that one also. So the least common denominator that we're going to be using to clear out all the fractions is going to be a 12. Repeat the process, distribute through, and solve. And there's one of these in your homework. Very, very similar to one of the questions in your homework here. I just had it a moment ago, but you can look in your homework and you'll see it. There's one very similar. Let's go ahead and finish it out. 12 divided by 3 is 4. 4 times 4 makes it 16x. 12 divided by 3 is 4 times 3 makes it 12. 12 divided by 4 is 3 times 2x makes it 6x. 12 divided by 4 is 3 times a negative 1 makes it a negative 3. 12's cancel, leaving you with an x. 12's cancel, leaving you with a minus 1. Combine on the left, so these can go together. That makes it then, let's see, what's that going to be, 32x, right? And add right here. So we're going to combine these together. So we've got a 16x and a 6x. Sorry about that, 22, not 32. I knew something wasn't right there. So that should be 22x. And then we've got a 12 and a minus 3. Well, that makes it a 9. The right-hand side is still x minus 1. Move that x over with subtraction. Move that 9 over also. And we're almost finished, because we now have 21x. The 9's cancel. The x's cancel. And it equals a negative 10. We're going to divide by our 21. And that leaves us then with x equaling now what? It looks like minus 10 over 21, doesn't it? If you ever have any questions, always ask. If I go through something too quickly or don't explain it that well, ask. You can always stop and make another example if we need to. What type of equation would this be? Well, this would be conditional, wouldn't it? I want to cover one more type of equation before we take a break. We'll probably get through a few of these. We'll come back and we'll do more of them. And the next type of equation that we're going to look at is we're going to look at literal equations. And literal equations are simply equations that have more than one variable. Simplest definition that I can come up with. So literal equations have more than one variable. So they're equations that have more than one variable. So any equation that has more than one variable is going to be what's called a literal equation. And we'll do a couple of these. We'll take a break, and then we're going to come back and look at a couple more, and then move on to the next section. So this is an example of a literal equation. So in a literal equation, we have more than one variable, and I have to specifically tell you what variable I want you to solve it for. So in this case, I want you to solve this for L. Now, right now, it's solved for P. We need to solve it for L. And when we solve it for L, that means we want L on the left-hand side and everything else on the right-hand side. So we want that L on the left-hand side. So let's begin by subtracting off 2W. That leaves you then with 2L equals P minus 2W. And we can finish this by dividing by 2 on both sides. Those 2's here, they can cancel. And that then leaves you with L equaling P minus 2W over 2. And just keep it as one fraction, just like that. And how do we know we're done? We have solved it for the variable what? L, right? And L is by itself on the left-hand side. We'll look at one more of these. And I'm going to pick this one from our textbook. So we'll do one more of these, and then we'll take a short break. So let's look now on page 111 at question 45. And this is S equals 2 pi RH plus 2 pi R squared. And they want you to solve for the variable H. So we're going to be trying to solve this for our variable H. Now the first thing we want to do is we want to find out where H is at. So we're going to come to our equation. We're going to put a box around this piece because this is the only piece, the only part that has an H in it. And we want to get this box all by itself. So let's move that 2 pi R squared over. So we'll begin by doing that. And that is then going to be S minus 2 pi R squared equals 2 pi R H. And we've got one more step. We want to get the H by itself. So we're going to put a box around that H. And how is the 2 pi R attached to that H? It's attached by multiplication. And what's the opposite of multiplication? Division, right? So how do we finish this out? We simply divide both sides by 2 pi R. And that is then going to solve our equation for H. So now we've got, those can cancel. Now we have H equals S minus 2 pi R squared over 2 pi R. And that's going to be your final finished answer. Okay. So let's now go ahead and take a short break. And let's try to meet back here at, let's say, 7:55. So try to meet back here in about 10 minutes or so. We'll meet back here at 7:55.